So on problem number 12, it says to find the point on the unit circle that corresponds to the real number t. So these are all of our unit circle values. When I see pi over 6, I always think of 30, 7 30s. That is the same as 210. The circle at 210, because if you think about the fact that that is just after 180, so it is end up in the third quadrant. That's going to be negative square root of 3 over 2 and negative 1/2. So the answer they want is right here. They want that point on the unit circle. Let's take a look at 12b. When I think of pi over 3, I think of 60s. So we have 8 of them. Now, 8 times 60 is 480. That's too much. That's higher than what we want. But if you do 480 minus 360, you'll be able to find the spot that we're at on the unit circle. So we're technically at the 120 spot. Now, 120 on the unit circle is the 60 reference that is in the second quadrant. So that point that they want as an answer is 1/2 negative square root of 3 over 2. Oh, I'm sorry. I have my positives and negatives. The x is negative and the y is positive. Next, 3 pi over 2. That's the same as 270. The point at 270, remember that's just on the unit circle pointing downward. That is the point 0, negative 1. Now remember what the points on the unit circle tell you. The x's are the cosine, the y are the sine, y over x is the tangent, and then you can flip them to find the others. So we've got our secant, which is the flip of the cosine, so just flip over that x. We have the cosecant, which is the flip of the sine, just flip over that y. And remember, tangent and cotangent are reciprocals. So if you know the tangent, flip it over, you got the cotangent, or cotangent is x over y, or cosine over sine. So there's number 12. Now for 13, I originally circled A, B, C, F, G, H, I, as you can see here. Please cross out B, H, and I. We're only going to do A, C, F, and G. So I've made up some graph paper down here below. So remember what you want to do. You first want to think about the 5 points that work for the original. So if we had y equals the cosine of x, the 5 points that work really nice are 0, 1, pi over 2 is at 0. Pi is at negative 1. 3 pi over 2 is at 0. And 2 pi is at 1. Now those are the original for the cosine. So if you think about order of operations, our 1/5 in front, you might recall, changes our amplitude. So we're just going to multiply all of the original y's by 1/5. So 1 times 1/5 is 1/5. 0 times 1/5 is 0. Negative 1 times 1/5, 0 times 1/5, and 1 times 1/5. Now on our graph paper, you just have to designate wherever you want 1/5 to be. And then I'm going to label my graph paper. So I'm counting every 2 and then putting a pi over 2. So let's graph the first period of our cosine. So at 0, we're at 1/5. At pi over 2, we're at 0. At pi, we're at negative 1/5, so let's call that negative 1. And then back to 0, and then back at 1/5. Now the instructions say to graph 2 periods of it, so just take the wave and continue it to the left. So you were up, so head down and come back up again. So there is A. Now let's take a look at C. So let's talk about what the original sine graph looks like. The original 5 values are 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, negative 1, and 2 pi back at 0. So that's the original sine function. Now what do these things do? Well, because it's by the x's, this is going to change our x values. Because it's on the outside of the function, that's going to change our y values. So let's take and set whatever's inside the parentheses equal to each one of our original 5s so we can find what the new 5s are. So if we do x minus pi over 2 equals 0, we get pi over 2. X minus pi over 2 equals pi over 2. We get pi. X minus pi over 2, and you might notice the pattern. We get 3 pi over 2. And so you might notice we're just counting by half pi's. It just kind of slid everything over to the right. So our new 5 values are pi over 2, pi, 3 pi over 2, 2 pi, and 5 pi over 2. So we're still counting by pi over 2's. Now remember, this is on the outside of our function, so it's going to take our original y and multiply by 2. So just take your original y's and multiply them by 2. So that's going to be 0, 2, 0, negative 2, 0. Now I'm still going to count by pi over 2's because it's going to fit, and I might have to extend my graph paper slightly to the right. So let's just say. Okay, so this is going to be pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. And same thing to the right. My amplitude has been changed to 2, so let's just make the graph paper fit. Now let's go ahead and graph it. So we're going to go at pi over 2, we're now at 0. At pi, we are at 2. At 3 pi over 2, we're back to 0, so there's our first bump. At 2 pi, we are at negative 2, and then at 5 pi, we're back at 0, that's the bottom. Now we want 2 periods of the graph, so continue the graph to the left, and so it's going to go here and up, there's the bottom bump, here and down, top bump. Okay? So there is our sine and cosine example. So knowing these patterns, possibly writing those down might be a good idea. Now I wanted to pick one tangent or cotangent and one secant or cosecant. So let's do these two next. F was y equals negative 2 tangent of 5x, and G is y equals 1/2 secant of x. So we'll do one tangent and one secant. And that's going to point you in the direction for a cotangent and a cosecant. Now remember, tangent is sine over cosine. So that is a good guide when you're graphing these. The way that the tangent works, now this is the original tangent. So at 0, your tangent is 0, undefined, 0, undefined, 0. Now that doesn't give us a whole lot, so you do have to remember how the tangent looks. We'll discuss that in a minute. So what's going to happen? Well, this, because it's on the x, is going to change our x's. So let's set all of the x's equal to 5x. So 5x equals 0 gives me 0. So we still start at 0. 5x equals pi over 2. Divides that by 5. Well, how do you do that? Well, just take the 5, multiply by 2. So that's pi over 10. 5x equals pi. That's pi over 5. And then that's 3 pi over 10. And then that's 2 pi over 5. Okay? So we need to count by tenths. So we can make our graph paper do what we want it to do. And what's the negative 2 going to do? Well, it's going to multiply the y's. Well, how does that really do that? Well, what we have to remember is the negative is going to flip it, the 2 is going to slightly stretch it. But it's still going to go 0 asymptote, 0 asymptote. Okay, let's draw our picture. So I'm going to count by pi over tens. There's 9 here, so let's make this pi. So then that's pi over tens. And then one more to the left, that's negative. Okay. And then we can make this 2 and negative 2. And I'll show you what to do with that in a second. Okay, so first always put on your asymptotes. So there's an asymptote at 1/10 and at 3/10. So 1/10, 3/10. So there would be one at 5/10. Wait a second, that's not 3/10. 1, 2, 3, there's 3. 4, 5, there's 5. There we go, if you were wondering. So, and then let's count to the left. And then put your zeros on in the middles. And remember, that's always going to be wherever your midline is or the middle of your graph. And since there's nothing added on, it's at 0. Now, what does the negative 2 do? Well, normally the tangent graph goes like this. Halfway is the pi over 4 mark, and then you go up 1. So go up and go down. So it looks like a cubit. What the 2 does is that just kind of stretches it up a little bit more. And so what the graph looks like now is it goes 2 to the left and 2 down to the right. So it goes up on the left and down on the right. Up on the left and down on the right. And what did that is the negative flipped those over. And even if you did nothing more than just flip them over, drew them for me, I'm good with that. Now remember, cotangents naturally look like this. So if they had a negative in front, you would have to flip them over. So that's what your graph for F looks like. Let's look at G. Let me give you a minute to write that down, and then we'll talk about G. Let's do a secant. Now remember, tangent has asymptotes where the cosine is 0. Cotangent has asymptotes where the sine is 0. Secant is the reciprocal of the cosine, so it's going to be related to cosine, and cosecant's related to sine, so it's going to have asymptotes where the sine is 0. That being said, if I do a secant graph, I actually first, before I do anything else, write down what the cosine is doing, because the cosine and secant go together. And so the cosine goes 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2 is 0, and 2 pi is at 1 again. Now that's what the cosine does. Now remember what a secant is. A secant is just going to flip or take the reciprocal of the y values. So if we just had a secant we wanted to graph, the same 5 x's are going to be our guide, but the y's, we're going to take the reciprocal. Well, reciprocal 1 is 1, then undefined, then negative 1, then undefined, and 1. So what does the 1/2 do? Well, it just takes those heights of 1 and negative 1 and multiplies them by a half. So now we know that each of those 1s and negative 1s become 1/2 or negative 1/2. But the asymptotes are still there in the same exact spot. Okay? So now we have everything we know. Remember, the secant bounces off the cosine curve. And wherever the cosine curve hits 0, it has to be an asymptote. So sometimes I just graph the cosine curve. Okay, so let's make this a half and this a negative 1/2. I'm going to count just kind of the way I did from the original, since we don't really have a change in our x. Okay, so let's graph the secant. So let's put on our points. So at 0, we're at 1/2, and then make an asymptote at pi over 2. And then negative 1/2, and then an asymptote. And then positive. Okay? Now I'm going to extend these a little bit so I can put another asymptote. Sorry, that's a little bit. And then remember, asymptotes are equally spaced, so you know what the original spacing is. So you can find more asymptotes. Okay? So it follows the cosine wave, so where there's an up, then the next one's going to be a down, so we can add a few more little bumps here. And remember, the cosine wave is sitting right here. And it's bouncing off of it. And so we get a parabola going up, bouncing off the top. And then one going down, and then one going up, and then one going down. And then remember, our cosecant is bouncing off of a sine. So I think that kind of gives you a good sense of the graphing, because it's been a while since we did the graphing. Okay, next, let's go back up and let's continue with problem 14. So for 14, it says evaluate the expression without a calculator. So that's going to tell you to use the unit circle. This little guide is going to be helpful. That just tells me I only have to look for answers for a cosine between 0 and pi, a sine between negative pi over 2 and positive pi over 2, and a tangent between negative pi over 2 and positive pi over 2. The secant works on these rules. The cosecant works on those. And then cotangent, since it's sine or cosine over sine, it works on those too. Okay. So let's go ahead and find the answers. Remember, our cosine is saying what angle gives me that answer? What angle gives me that answer? Now we're looking for unit circle angles, so I want radians. Unless, if you notice, if it's multiple choice and they gave you degrees, look at degrees. I kind of do radians. I find the degrees in my brain, and then I flip them to radians anyway. So, okay, anyway, so let's look at 14a. 14a says, what is the arc cosine of square root 3 over 2? Well, if we look between 0 and pi, the cosine is square root 3 over 2 at pi over 6, because the point there is square root 3 over 2 1/2. So the answer is pi over 6. B means the inverse sine or arc sine, and we want to know where is the sine negative. Well, that's going to be the negative version of pi over 4, and so the answer is negative pi over 4. Now, tangent's a little harder. When I see the arc tangent of negative square root of 3, I think it was negative square root of 3, negative square root of 3 over 1, which is negative square root of 3 over 2 over 1/2. So that the 2's, remember, end up kind of canceling out. So what point on the unit circle gives me the sine value negative square root of 3 over 2 and the cosine value 1/2? Well, we're talking down in the fourth quadrant, and the sine is the higher one, square root of 3 over 2, at pi, the pi's over 3. So the answer is negative pi over 3. Okay, so we are going to stop there. When we continue, we are going to continue with problem number 20. So expect that. And there you go. Just one second.